Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on Introduction to Statistics, or Probability and Statistics, specifically counting. So we need to go over some definitions here. The first one would be equal sets. A set is just a group of collection of things. So if each set has the exact elements, they're called equal sets. So elements are things inside the set. So set A is the elements 1 and 2. Set B is the set elements 1 and 2. If both of them have exactly the same elements, then we could say that set A is equal to set B. Another definition here, we have a subset. Subset is if each element of the first set is an element of the second. So going back to our previous example, is everything that's in A also in B? 1, 2's in A, 1, 2's in B. So then we would also say that A, here's a symbol, A is a subset of B. Now, it doesn't have to be equal. If I put a 3 in set B, then in set A is 1 and 2, and B still has 1 and 2. It also has 3, but it has at least everything that A has, a subset. Now, just a quick review, or something kind of new here. If I were to put, let's say, a 3 here, then A is a subset of B still, because 1 and 2 is also in B, 1 and 2. But we could also say that A is a proper subset of B. A proper subset is a subset in which the sets are not equal. Right now, our sets are not equal as I have them drawn right now, 1, 2, and then 1, 2, 3. So they're both subsets of each other because 1 and 2 is in A and it's in B. But since B has an additional element, they're not proper subsets. Or excuse me, they are proper subsets because there is something in B that's not in A. All right, so that's kind of the difference. A proper subset means that the sets are not equal. And another thing that we're going to really quickly talk about, the empty set. The empty set is a subset of all sets. So I'm just going to write all sets. The empty set is a subset of all sets. All right, so here I have a set I'm calling J, and in set J are Jack, Joe, and John. All right, Jack, Joe, and John. There are what we call 3 elements. And so the notation that we use to show the number of elements is in this case, J, the number of elements. And how many elements are there here? Well, there are 3 elements, or 3 members. So the number of elements in this set J would be 3, Jack, Joe, and John. We would write these out in brackets and say, well, we got Jack, there's 1 element or member. We have Joe, and we have John. This would be set J is equal to these elements. This is kind of a notation of how I'd write sets and their elements. Now let's go back and think of subsets. What are the subsets of set J? Well, first of all, the empty set is a subset. We could have the set just Jack. We could have the subset just Joe. We could have the subset just John. We could have the subset Jack, Joe. We could have the subset, etc., Joe, John. We could have the subset Jack, John. We could have the subset Jack, Joe, John. So there is a way to figure out how many subsets a set would have, and that's just simply 2 to the n power, where n is your number of elements. So in this particular problem, there would be 2 to the third, which is 8. There's 8 different subsets that can be formed. And again, let's go over those. You got the empty set, it's 1. You got Jack would be 2, Joe would be 3, John would be 4, Jack and Joe would be 5, and then if you wanted to list the other ones, you could have Jack and John would be 6, you could have Joe and John would be 7, and then you could have Jack, Joe, John, all 3 of them is still a subset, that would be 8. So 2 to the n is how many subsets that you could have. So if you have 3 elements, you could have 8 different subsets. one of the important formulas that we're going to encounter here, called the counting formula, says this: the number of the union, the combination of A union B, or A or B, is equal to the number of elements of A plus the number of elements of B minus the number of the intersection of A intersect B, or A and B. So let's take a look at a problem that would use this counting formula. Now, this formula is used when you're trying to figure out how many of something that you would have. If both sets are completely different, have no common elements, then you could take off the last part minus the intersection of the two, because there wouldn't be any intersection if none of the elements are common. And that would just be called the additional principle of counting. All right, but this one would work if there are some things in common. So for example, here's a problem. Let's say you have 100 students. You have 35 that are taking algebra, 52 that are taking science, 18 that are taking both. They're taking algebra and science. If a question were how many students were registered in either college algebra or science, then what could you do? All right, well, you'd have something like this. Have a Venn diagram, 35 in algebra, so 17 that's not in an intersection, and 18 that is in an intersection. And then in the science, you have 18 that's in the intersection, 34 is not, so a total of 52. Now, the way that you would figure out how many is in either algebra or science is you'd say, okay, the number in algebra is 35, plus the number in science is 52, minus the number that's in both, so it's 18. So 35 plus 62 is 87 minus 18 would give you 69. So there's 69 students that's in either algebra or science. Right? So this is the counting formula. You simply take the number that's in each element and then subtract that by how many is in both. Now, if none of these were in both, say that both wasn't there, then it would just be 35 plus 52. All right? But since some of them overlap, you can't count those again. All right? So there would be 69 in either, which also means that there's 31 that's not taking algebra or science. 31 students are not taking algebra 1 or science. The next thing that we have is the multiplication principle of counting. The multiplication principle of counting is sequence of choices P times Q times R, where you have P selections, Q selections, R selections. So I just have an example down at the bottom. Let's say that for dinner you could have a soup and a salad. And then for your entree you could have a fish, turkey, or chicken. And then for dessert you can have pie or cake. How many different ways are there to make up this decision? Well, according to the thing, we'd have 2 choices for our appetizer, and then we'd have 3 choices for our entree, and then 2. So when you multiply this out, 2 times 3 is 6, times 3 is 12. All right, now you could write all these out. It would take a while. You could either have soup first, and then fish, and then pie. You could have soup first. You could have turkey, and then pie. You could have soup, chicken, and pie. And if you continued, you could keep going. There would be a total of 12 different possible options to choose from. So this is called the multiplication principle of counting. You just multiply your selections. All right, so if you have P selections, then Q selections, then R selections. Just keep multiplying, depending upon how many that you have. Let's take a look at 2 examples. This one right here, I have a Venn diagram, and first question is how many elements does set A have in it? So you look here, it's not just 15, it's everything in A. So you got 15 plus 3 is 18, plus 5 is 23, plus 2 is 25. So it's a total of 25 in A. Now, the next one says A union B. Well, this is going to be A and B together, so this is 25. Now, how many does B have? B has 20, minus how many they have together. They have 8 together, so 25 plus 20 is 45, minus 8, which is equal to 37. So A or B would be 37. Hope this helps. God bless.